children, today we will move ahead with our syllabus, that is electrolysis. We have already completed the process of electrolysis. Now today we will speak about the applications of electrolysis. Is electrolysis useful? Where do we use it? Yes, so the important applications of electrolysis are three. First, electroplating. Then electro refining. And third is electrometallurgy. Electroplating, electro-refining and electrometallurgy. Let us first start with electroplating. Okay? In electroplating, now what do you mean by electroplating? Let us see what is the meaning of electroplating. Electroplating means coating of one metal over another to enhance the properties of that metal. Like, suppose if I have only a silver bangle or something, silver chain of the watch, I want to give it a look of gold. But I don't have enough money to buy gold chain. So what will I do? I'll buy a silver chain and get it electroplated with gold. Then the amount of gold needed will be less in that case, and the resultant, after electroplating, the resultant watch, the chain will look exactly like gold. It will give the appearance of gold. So one reason is that. One reason why we do electroplating is for getting, enhancing the appearance, enhancing the look of a particular metal. Okay, if something is made of iron, I can make it look like silver by electroplating with silver. So, to enhance the appearance. Second, why do we do electroplating? Second reason is to, and that is the most important reason, that is to prevent or minimize corrosion. Minimize corrosion. Okay, so metals like iron, which is very easily gets rusted and corroded, we can plate it with something else like nickel or chromium to make it last for a longer time. Like the shining parts of your bicycle, you might have observed that they look very shiny and beautiful even if it is made of iron. What is the secret behind that? It is made of iron, but it is electroplated with either nickel or chromium to give that shiny appearance, shiny beautiful appearance. Okay, so two purposes are served there. It is looking beautiful also, and it will help the prevention of corrosion. So that is the two reasons why we do electroplating. One is to give it a better appearance, better look. Secondly, it is to prevent corrosion. Now, there are a few points that we have to remember during the process of electroplating. Let us see which are the points that we must keep in mind. First point to be kept in mind is the article to be electroplated. The article to be electroplated should be made the cathode. Why? Because we know, already you have seen 4 examples of electrolysis. You know that during electrolysis, the metal gets deposited where? The metal gets deposited always on the cathode. And in electroplating, we want the metal to be deposited. So, whatever article that I want to electroplate, if it was my watch chain, then I will put this chain and I will make it the cathode. Okay, I will connect it to the negative terminal of the battery, then this will become the cathode. Okay, so the article to be electroplated should be the cathode. Second, the metal with which the article is to be plated, electroplated, should be the anode. Okay, the pure metal, pure thin strip of metal should be made the anode. So from the anode, the active anode, the ions will get into the electrolyte and come to the cathode to get deposited. Okay, so the anode should be the metal with which you want to electroplate. Okay, see, then the electrolyte should contain what? Electrolyte must contain the ions of the metal to be ions of the metal with which electroplating is to be done. Okay, then a low current is to be used. If you need a uniform deposition, if you want a uniform deposition on the article to be plated, then a low current should be used, and for a longer duration. If you want a thick coating, you have to put it for a longer duration. If you want a thin coating, it should be for a shorter duration. So low current for a longer duration. Okay, low current for a longer duration. And last we must ensure that we are using a DC current. A DC current should be used, not an AC current. A DC current is to be used and not AC current. Okay, why cannot we use AC current? Because AC current keeps changing its direction. Yes, and when the direction keeps changing, what will happen to the electrodes, the cathode and the anode? One moment, if this is the cathode and this is the anode, then the next moment what will happen? This will become the cathode and this will become the anode, because the direction of the flow of current has changed. So because AC current keeps changing in its direction, the electrodes will also keep changing, cathode and anode. And if the electrode keeps changing, there will be no effective deposition. Why? Because one moment, if one ion is deposited on the cathode, the next moment that cathode will become anode and the ionization will take place. From there, whatever is deposited, it will ionize and come back to the electrolyte. So there will be no effective coating. Okay, so these are the 5 points you must keep in mind, children, while doing electroplating. First one, the article to be electroplated should be placed as the cathode. The metal with which the electroplating is to be done should be made the anode. The electrolyte must contain the ions of the metal with which we are going to electroplate. If it is gold, then gold ions should be present there. A low current for a longer duration should be used, low current wise, to ensure a uniform deposition, okay. And DC current should be used and not AC current, because AC current will keep changing the direction and the electrodes will keep shifting and there will be no effective deposition, okay. Now, in your syllabus, you have got two types of electrode, two electroplating, that is electroplating with silver and electroplating with nickel. Electroplating with silver and electroplating with nickel. So keeping in mind all these 5 points, let us see when you do it with electroplating with silver. Then what will you take as the electrolyte? What should be your electrolyte? Your electrolyte should be either sodium argentocyanide, or potassium argentocyanide. So electrolyte should be either sodium argentocyanide or potassium argentocyanide. Then what will happen when, if you are taking sodium argentocyanide solution, then you will get, on ionization, what will you get? Na plus Ag plus Cn minus, but there are 2 Cns, so 2 Cn minus. So this is the thing. H2O, what solution it is, so water will also give H plus OH minus. Now at the cathode, what will happen? At cathode, suppose now let me tell you that we have to a brass spoon I have to electroplate with silver, okay. So cathode will be what? Cathode will be made what? The article to be electroplated, and here what are we taking in the question? What is there? Brass spoon. So cathode will be brass spoon, okay. And anode will be what? The metal with which we are going to electroplate. With what are we going to electroplate? With silver. So the silver, thin pure strip of silver will be my anode. So silver will be my anode. Okay. Now at cathode, what will happen? Who all will go to the cathode? Na plus, Ag plus and H plus will go to the cathode. And who will get discharged? Depending upon the relative position of the in the electrochemical series, Na plus is right on top, then H plus, then Ag plus. So Ag plus is down, so Ag plus will get discharged first, Ag plus, and Na plus and H plus will be called what ions? Spectator ions. Yes. So Ag plus will take up one electron and become Ag. Ag is a silvery white metal. Silvery white metal will get deposited where? On the cathode. On the cathode means on what? On the brass spoon. Okay. At the anode, what will happen? Who all will go to the anode? OH minus will go and Cn minus will go. But none will get discharged. Why? Because the anode here is active. What anode have we taken? Silver. Okay. So silver, Ag metal, will give up one electron and become Ag plus. It will become Ag plus. So this Ag plus will get into the solution, will get migrated towards the cathode and get deposited here. So what will happen to the mass of the anode? The mass of the anode will go on becoming smaller and smaller, and then we have to replace the anode. And what will happen to the mass of the brass spoon or the cathode? The brass spoon will get heavier and heavier because silver is going on depositing on it. So this is electroplating with silver, children. Why instead of sodium argentocyanide, why can't I easily take a very simple salt like silver nitrate? Why to take a complex salt like this? So I will, why? Because silver nitrate, if you take, the ionization is very fast. Very fast deposition will take place and it will not be even. It will not be even. Uniform deposition will not take place, and that is why we don't take silver nitrate, but instead of that we take a sodium argentocyanide. Okay. So this is so what all you must remember here, that the article to be plated has to be mentioned. So if you are telling, don't write in the answer, if the question comes that what is the cathode, don't write the article to be plated. You have to see in the question which article is being talked about. Here if it is being talked about the brass spoon, you will write brass spoon is the cathode. What is the anode? A thin pure strip of silver. What is the electrolyte? Sodium argentocyanide solution. What else? Nothing. So as the cathode reaction, the anode reaction you must know. Observations you must know. What happens at the cathode? Cathode, there will be a deposition of a silvery white metal. And what happens at the anode? The mass of the anode goes on decreasing. That is it. Okay. Now let us see if we have to do it with nickel. The next one in your syllabus is nickel. So when we use nickel, then what will happen? When we use nickel, suppose I have to electroplate an iron bell with nickel. Iron bell with nickel. If it is given in the question, iron bell. So which electrolyte will I take? Nickel sulfate solution. Nickel sulfate solution. Ni2 plus SO4 2 minus H plus and OH minus. So ionization reaction will take place like this. Then we come to the cathode. Cathode reaction. What is the cathode here? The iron bell. Okay, the iron bell is the cathode. And what will be the anode? Anode will be the pure thin strip of nickel. Okay, so here what happens, let us see. Nickel and hydrogen both will come, but because the concentration of nickel is more, then Ni2 plus 2 electrons will become nickel. And at the anode what will happen? Ni minus 2 electrons will give Ni2 plus. And what will you observe? A shiny grey metal nickel is deposited on the iron bell, and the anode goes on decreasing in size or shrinking in size, and you have to replace the anode from time to time. So that is it. Nickel sulfate is the electrolyte. Remember, we use here nickel sulfate solution. So that is about electroplating with nickel. The second application and the third application, children, both the two applications, electro refining and electrometallurgy, both we use in metallurgy, extraction of metals, and that also depends upon the same principle as this one. Electro refining means what? Using electricity to refine a metal from its impurities. Okay, so impurities are removed and the metal is got in the pure state, electro refining. Electricity is used, and in electrometallurgy means what? Extraction of the metal from its ore using electricity. So both these will use the same principle which we use for electroplating, and that is active anode. So in electro refining, remember, when we do electro refining, what will be our cathode? A cathode will be a thin strip of metal. That is, which if we are refining copper, then a thin strip of copper will be the cathode. Because why thin strip? Because from more and more copper will come and deposit on this thin strip and become thick. Anode will be what? The impure metal. That we have extracted. That impure metal will be made the anode. From the impure metal, only the copper, if we are taking copper refining, then only the copper ions will move towards the cathode and get deposited. So what should be the electrolyte then? The electrolyte should contain ions of the metal which we are electro refining. That is copper sulfate if we are copper metal if we are refining. So copper sulfate solution will be our electrolyte. Okay. Same principle. Active anode, and anode will go on becoming smaller and smaller. Cathode will go on becoming heavier and heavier. Third one is also same, electrometallurgy that we said. Electrometallurgy also. What is the cathode? Cathode is the thin strip of the metal. And what will be the anode? Anode will be the ore, metal ore. Okay, from the ore, the metal will go on getting into the deposited on the cathode. Okay, so this two, electro refining and electrometallurgy, has the same principle as that of electroplating, and that is the active anode principle. Okay, so and these both we are going to see all in the chapter of metallurgy, where we what we have in our syllabus is aluminium, and aluminium uses both. The electro refining is also done by electricity, and extraction of the metal is also done using electricity. So both these we will see, nothing to discuss in detail here. That's all in this chapter, children. I hope you have understood it well, and now you will be able to answer all the questions given in your exercise or in other books.